Third up today is combining uncertainties when you're multiplying and dividing quantities. So here we've got a resistor and we've got the PD across it and the current through it. So we could calculate the power of the resistor, nice and easy, 2 watts. But what's the absolute uncertainty of that? 2 plus or minus how many watts? Well, when you're multiplying quantities like we've done here, you have to add the percentage uncertainties, not the absolute. So, first of all, we have to calculate the percentage uncertainties of I and V, and there they are. Then it's I times V, so we have to do the percentage uncertainty of I plus the percentage uncertainty of V, and we get 6%. Okay, so the uncertainty we're looking for is 6% of 2 watts. And whichever way you want to do it, 6% of 2 is 0.12. Finally, we absolutely must remember to round to one significant figure there. And then in our last step, this you should do, but you won't lose a mark for it if you forget, this is 1 decimal place, so that needs to be 1 decimal place as well. I'm also going to calculate the resistance of the resistor, and so I get 2 ohms. Now, it doesn't matter whether I'm multiplying or dividing my quantities, I still add the percentage uncertainties. So here we go again, the percentage uncertainty of R, because we're dividing, we add the percentage uncertainties of V and I. So again, plus or minus 6%. However you want to do it, 6% of the value. Absolutely must round the absolute uncertainty to 1 sig fig. And then, if you can remember to, in the final answer, that's 1 decimal place, so this is rounded to 1 decimal place as well. The last thing to say on this before we try a question is that exact numbers don't have any uncertainty. So if we calculate the area of a circle, the pi has no uncertainty. Kinetic energy, the half, has no uncertainty. And volume of a sphere, the 4, the 3 and the pi, none of them have any uncertainty. So when you're calculating percentage uncertainty, that's also 0. Okay, it's not about electricity, but here's an example question. Right then, cross-sectional area is pi times r squared, and radius is diameter over 2, so the cross-sectional area is pi times d squared over 4, or I've written it out in full here, so we've got pi times d over 4. So we're definitely multiplying and dividing, so we're going to be adding percentage uncertainties. So the percentage uncertainty of d is absolute over the value, and that comes out as 1.25. Now, the percentage uncertainty of A, the pi doesn't have any uncertainty, the 4 doesn't have any uncertainty, but this D has that much and this D has that much. So the percentage uncertainty of A is 1.25 for that D plus 1.25 for that D, and the correct answer is A.